So next up, we have Nikhita Singh, the co-founder and chief product officer of Artificial. Nikhita, it's all yours.
Thank you. And thank you guys for having me for this talk. As Dulcie mentioned, I'm Nikhita. I'm co-founder and chief product officer at a startup called Artificial. And we're building software tools to make it easier for scientists to automate and leverage robots in the lab. So I wanted to take this session to talk about this phase that I think every startup goes through, which is really this early stage discovery and moving towards productization that you can actually deploy in the real world. So to give you a little bit of background of who I am and why you're listening to me today, I have devoted my time and energy to figuring out ways in which we can make robots and automation more accessible to people. And I've had the opportunity to do that in a range of different places, including surgical robotics, in education, in the home, in assisted living, and even taking a robot into zero gravity. And one of the things I realized in all of these experiences is that when you take robots, you couple them with humans, and then you throw them into an unstructured environment that's constantly changing, things get really, really difficult. And so what you end up with is that a lot of robotic applications never make their way to environments that have a ton of people and have a lot of factors that are changing day to day. So at the top in the left, you see the automation factory for building a car in the 1930s. And next to it is what that looks like today, where there's a ton of robots, they're behind safety fences, you don't need a ton of people, and you can sort of do the material in, car out type of philosophy. Now on the bottom, you see a lab in the 1930s with Alexander Fleming, and you see a lab today. And a lot of the way that lab work is actually done looks pretty much the same, other than the cigar, I think, is in that picture. And so the reality is that, science is always changing. We're building incredible therapies. We need to give tools to our scientists. But because everything evolves at a really fast pace, robots and automation don't make their way to these type of environments in the way that they should. So the question it really leaves you with is like, why is this the case, right? Why can't we solve this fundamental problem, even though we would all probably agree that it's necessary to? And I think in my experience, having looked at this in a host of different domains, it breaks down into these 5 core needs. The first is that robotic systems are really hard to inspect and use. So if you've ever watched a person walk up to a robot, they often have no idea what it's doing other than blinking at them with some lights and trying to tell them what state it's in. Now, even if you get past that and you want to get a robot to run, wrangling it and getting it to do what you want it to usually requires a ton of software expertise and the guy or girl who knows how to wrangle the Hamilton and being able to hire them into your company. The other challenge with this entire process is that the software tools that exist in labs or other environments barely talk to each other. So you have people taking USBs with data and walking from one system to the other to make sure things move the way that they need to. And because of that, you end up having humans very much in the loop at every step of the process. But most of the tools that we deploy in these contexts don't consider that to be a reality. So everyone's focused on the robot, no one's considering the fact that on the boundary of each of those automated systems, there's an actual human interaction that needs to happen. And finally, if you want to get a robot to do what you want it to do, it needs to know about all the nouns and verbs and things that are happening in its environment. And because in these unstructured environments, there's a lot going on, most of our data models don't actually represent everything we need them to get our robots and automation to behave in the ways that we want. So that was really the impetus for building Artificial. And our vision was that, hey, this is a reality we want to solve as a group of roboticists and automation experts who've seen this in a bunch of different domains. Why don't we take all of these tools and bring them to an environment that really truly needs it in order to scale their operations? And the first thing we did going from this vision was to say, cool, let's go shop it around and go talk to people. And the first skepticism that I heard was like, that's a cool idea, but every lab is so different, you're never going to be able to generalize a solution. And I think this is like a really critical juncture for a company where you go from a vision, which is the reality you want to create and hope that exists in the world, to an actual product definition, where you're adding constraints and testing if that vision actually has legs. And when you're working on a really complicated domain, one of the challenges that emerges is deeply technical people talking to deeply technical people get lost in the complexity of what they're doing day to day because they see it as their unique and differentiated value. So you never really get the conversation to a point where people are driving towards a generalized scalable solution that can be shared across different labs, across different contexts. But if you look at the tools we use day to day, like even like Excel or my personal experience at Palantir, there are many tools that exist across domains, right? An accountant uses Excel, but so does a scientist. And we've been able to find common ground that can work across many, many different contexts. And so really the challenge that emerges when someone gives you the skepticism is like, you're not actually acquiring the right data because you're too opinionated about the solution that you're putting forth. And so we took the challenge and started to look at this a different way, which is what if we went and talked to the people on the ground and left our opinion at the door? And so we went and talked to about 200 different scientists, automation engineers, and operators in the lab, ranging from folks in early stage discovery all the way to big pharma. And we never went in with, this is a solution we want to offer you, but instead spent all of our time on understanding the little moments of friction that exist in their day-to-day and trying to consolidate as much information as we could find. I think one of the big learnings for me at this point was, as a product person who's operating in a company, your job really is to be a professional question asker and go into the world, leave your opinions at the door, and just try to put yourself in your user's shoes so you can try to understand the little bits of information they can offer. And what this allowed us to do is get, one, hundreds of pages of interview notes that I then had to go through, but really more importantly, take parts that people resonated with and start to group them as ideas that came up over and over again. I like to think of this a little bit like high school where you're highlighting things in a notebook in a sense. And the things that we learned from our users was that oftentimes there was just way too many interfaces to deal with. So they didn't want to get trained up on how to use all this different equipment. Because all the equipment and the plates and tubes were moving around, it was hard to know where everything was in a particular lab. And then when they brought in a new scientist or a new lab assistant to actually work in the lab, it was hard to train them up on all the complex steps that they needed to know about and all the little esoteric details. On top of that, when you talk to them about automation, users were like, well, I don't really know if I want to buy an automated system because we have a blend of manual stuff that Joe has to do on the bench, and then part of it is automated. So what's the point in spending all of this money to just have an expensive paperweight that sits in the corner? And finally, for the labs that actually had automation, it was really difficult for them to know what was happening in the lab at any given point, especially if they weren't physically there. And this became more and more relevant through the course of the pandemic, where labs weren't able to have everyone there physically, and they needed to know if things were running as predicted. So we took all this information and we were starting to make sense of it. And I think the pivot that a company has to go through once you seek all of this inspiration is start to add constraints. So we threw out some of the inspiration and said, we don't want to work on these problems, but then started to zero in on the problems we did want to work on and put them in little boxes. I often think in my experience, in the early stages of a startup, constraints are undervalued. And I think it's really important to be able to say no to things and define the boxes in which you do want to operate so you can translate your role back to a customer. So we took these core needs, put some boxes around them, and they became the frame with which we built our 4 applications. So what you see here today is the genesis of Artificial as a product suite that has 4 core applications that each tie to a user need that we heard about through that discovery process with over 200 people. So if I dig into labs, the first need that users told us about was that every automation engineer has all this knowledge in their head about how things fit together and where they need to go. And so we took all of that knowledge, talked to a bunch of automation engineers, and started to encode it into an actual tool. So what you see play out in this video with the blues and the greens and the highlights is we went to equipment vendors, got the models for their equipment, and started to overlay it with what we call common sense lab physics. So we wanted to lower the barrier to entry so that a scientist or any user didn't need to rely on all this esoteric knowledge that had been accumulated over years, but could just quickly drag and drop and build out a model of their lab environment without having to worry about all the esoteric details that were in the mind of the automation engineer all the time. From here, a need we often heard about was, how do I get people trained and ready to use this equipment in my lab? And so we took that digital twin and started to overlay this markdown editor. So here users could go in and describe the protocol they wanted their lab assistants or their scientists to actually run and tie it to pieces of equipment that were in the actual physical lab. As we did more user research on this front, we learned things like people wanted to put in warnings because they often made mistakes on the plate orientation or where things were positioned, and that would lead to costly experimental errors down the road. So we added in features for things like warnings and videos and annotations to really reduce that friction and make the user have all the context that they needed in order to run a protocol effectively. So I think this really highlighted for us the importance of control and tools that would give this value back to our end customers so that they would be able to customize this and work on this on a daily basis without us having to be part of the loop. The other part that a lot of our customers talked about, well, I guess in this case, this shows you the assistant being able to play out for an actual operator. And so that thing we built with the markdown language, they can now give to a lab assistant that was physically in the lab and checklist through each of these steps in the digital twin and know exactly what they need to do at any given point. Another problem we often heard about, like I mentioned, was being able to stitch together automated steps with manual steps, because lab processes are rarely as simple as just a robot running. And so we started creating these workflow tools so that users could stitch together, here's like a manual step I need to do with an automated step that the robot needs to do, and then some more manual work that needs to happen, and describe processes in this new way versus just the robot running by itself. And most importantly, and this became incredibly important in the pandemic context, we created tools so that users could have a command center for their entire lab. So in this case, they could walk in, you would see one single software ecosystem for all the equipment in your lab environment. And we started to create ways in which they would know which equipment needs their attention, like the yellow device that you see there, and which equipment is running like it should. And they'd be able to dig into the experiment and see how far it had gotten since they initiated the run. A really important part about building this piece was the fact that we actually took on customers that were remote. And so we're a remote company. The pandemic made us extra remote, and we were not in our lab's physical space. And so it forced us to create the tools to be able to do all of this remotely and also build that functionality for our end users. So they could go into a browser, just log into their lab and be able to see this from anywhere and decide if they needed to physically be present to take action. I think the way that, I shared this story in the 15 minutes, a lot of this can feel really linear. But in practice, I think the chaos of going through this process is very much like volatile and has its ups and downs. And so, what we started with as building a thesis then became this process of validating it in the real world. So we took this concept of products that I shared with you and the 4 applications in this case, and we took it to customers and took it to about all the users we talked to before and tried to see if it resonated with them. I think one of the biggest learnings for me at this point was that the way in which you communicate what you're solving to your end user can fundamentally change the way they understand that information. So when we pitched it as one platform versus 2 applications versus the 4 that you saw today, it very much changed the frame of how they saw what we were doing to fix their day-to-day and solve their needs. So I would urge anyone to try different ways in which you pitch it back to your customer as a series of applications or how you define your product. Through that process, we found a customer champion who was willing to actually let us take everything we learned and prove its value in their lab context. I think at this stage for us as a company, and many other companies at the same point, you realize that you don't have the feature set to be able to just deploy and leave and let them tell you if it's useful or not. And so you really want someone who's invested in that vision with you and is willing to be patient. So when you tell them that, hey, I need an extra month to build this feature you're asking for, they're willing to go along on that ride. And we were fortunate enough to have a customer who was willing to be patient and stick by us over a long period of time in order for us to really hone in on our tools and build a foundation that worked. And so when we went back to the same trade show we were at a year ago testing our hypothesis, he went and actually pitched what we had built together over the past year. So Bob Ganser, who's the head director of automation at Beam Therapeutics out in Cambridge, actually went and talked about our experiences together. And that allowed us to then find N equals many and a lot more customers that were wanting to see the same product deployed in their context. So this is very much the phase we've been in recent months where we've been focused on taking that same product, deploying it on all these contexts, And I think the biggest learning for us at this point has been learning how to say no and defining those boundaries even closer. Because the reality is that in the first phase of a startup, you always want to say yes. You want to get your foot in the door. And then at some point, you have to realize that to ship an MVP out the door, you really need to say no and calibrate the little bit that you want to build and build really, really well. And so in doing that, we've been moving ourselves towards this goal of productization as we scale, where all of these tools that you saw me snapshot today can actually just be given to users and they can run with it without us being part of that process. So I think for me, like it's really, this journey looks linear in a sense, but there's many moments of feeling like maybe the problem is intractable, or maybe I shouldn't work on it, or maybe it doesn't make sense. And for me, the thing that helped the most is having a core set of customer advisory people that I can always go back to be re-inspired. Because when you go back to them and they're invested in your vision, they'll give you the inklings of things that make you go and try again and maybe edit your thesis just a little bit. And so I cannot overstate, the importance of having a core group of users that care about what you're trying to build and will be continually re-inspiring you as you go through this entire process that is a lot more chaotic than is evidenced on this slide. So hopefully that sort of sharing that story in the context of artificial helps you see, different ways that a company can go through this process. I think it's really important when you're doing something deeply technical and working with really technical people to build a language with which you can engage with them and understand the details of what they want to accomplish and chip away at that problem slowly. So happy to answer questions, and thank you guys for listening.
Awesome. Thanks, Nikita. That was incredible. So one of the questions from the audience is, what particular types of questions did you ask to get at sort of those little bits of friction? Sometimes it's easy to ask confirming questions for what you have versus the user needs and challenges. So do you have any sort of actual question archetypes that you use to try to push that boundary a little bit?
Yeah. I think the thing that I value most is actually observing. I cold emailed a bunch of integrators and labs and asked if I could fly in the wall without being annoying to them for a day. And so I actually ended up spending a bunch of time just watching in the corner and just seeing what they did. And that allowed me to have a frame for, what is it that they spend their day on and what moments of friction do I think they have? And then when it comes to asking questions, I think the biggest part was to leave an opinion out of the question. We often want our users to do the work for us. So it's natural to be what do you hate about your task management software, right? And that's actually you asking the user to solve the problem for you. I think a better way to look at it is to ask, what do you do every day when you open your computer, right? And I often like to get into it with people they're well, this is what I do. I'm cool, so what keys do you type, right? And walk me through it more. And so I think leaving the opinion out of it and observing more than talking all the time, I think can yield a lot of value.
Awesome, that's great. So as a professional question asker, what surprised you the most about how science is currently done? And so let's start with that question first. Was there something that was particularly surprising when you were asking all these questions?
Yeah, so I had a dream of being a scientist 15 years ago when I was an overachieving high school nerd. And so I used to work in all these labs. And, one of the things that always stuck, I used to bring liquid nitrogen and be pipetting all the time and probably useless to all of the postdocs that were managing me, I think. But coming back to this domain after my rebellion into robotics, 15 years later, I think this thing that stuck with me the most is a lot of lab notebooks looked the same as when I had to describe things, and the Post-its were the same. So a lot had stayed the same, but the instruments and what we were doing with them were getting better. So it's the surrounding pieces are all the same, but the boxes are getting smarter. And it makes you sort of question well, why hasn't the job description changed, right? Why isn't a scientist spending more time being creative versus dealing with the complexities of their pipetting and their operations? And so I think the thing that surprised me the most was a 15-year adventure back actually didn't feel that different, and I expected it to feel sort of a completely new world in a sense. So.
That's amazing. That's actually super interesting. Okay, I think we have time for one more quick question. So, and it's quickish. But you spoke to the group about a group of trusted customers that will continue to inspire you on sort of your road to productization. How do you know you've actually gotten that group of customers right in terms of what you're trying to build?
I think for me, it's really about convergence, right? Like you put out a thing and then you hear it from n equals 2 and then n equals 3. If they're asking for completely different things in what you pitched, there's a problem with you as a company, right? And so the moment you start to see convergence and they're actually arguing with you about the details of what they want, that's a really nice place to be, because you can say no in the details and the specific checkbox in your statement of work, but you can't say no to a completely like new thesis, right? And so I think when you start to see convergence of ideas and your customers are better at repeating back what it is you're offering to them, to you, that's when you know you have something you can deploy, in my mind.
That's awesome. Convergence is a great word. So we're out of time, Nikhita. So thank you so much. This was really thought-provoking and I think really insightful about how the road to productization. So thanks for sharing your time with us today. And we should catch up soon. So thank you.